Hello mathematicians. Today's video is on permutations and combinations, and so our objective for the day is students will be able to determine the number of outcomes. Go ahead and pause the video if you need to take a minute to copy this down. Alright, so the first two things we're going to talk about is combinations and permutations. I want you to copy down these two definitions, pause the video, copy down the definitions, and then press play when you're ready so that I can talk you through the difference between a permutation and a combination. So a combination is an arrangement where order does not matter, and a permutation is an arrangement where order matters. To give you an example, combinations and permutations are a way we figure out how many different possibilities something can have. And so, for example, an example of a combination would be, let's say that you have a blue shirt, a brown shirt, and a white shirt. And let's say you have black pants and brown pants. And you want to figure out of those three shirts and those two pants, how many different outfits can you create? We call that a combination because if you wear a blue shirt and black pants, it's the same as wearing black pants and a blue shirt. It doesn't matter what order we say the outfit in, the outfit is still the same. A permutation is an arrangement where order matters. So the order that you say something in or the order that you put something in matters. An example of a permutation would be a locker combination. If the combination to your locker is 2, 3, 4, then you have to put the number 2 in first, the number 3 in second, and the number 4 in third. If you were to try to put that locker combination in a different way, let's say you tried to put in 4 first, 2 second, 3 third, your locker would not open. So a permutation is where order does matter. And so I want you to just put a quick way of remembering this is a locker permutation, right? If we really think about it, you call your locker a locker combination, but really it should be called a locker permutation because order does matter. And as we go through different situations where we're trying to figure out, well, how many possibilities are there for these different situations, I want you to think about it in two ways, okay? We have an event or a category, and for that event or category, we're always going to be thinking about, well, what are the number of choices, or what are the number of possibilities? We're going to start today's lesson off with something called a tree diagram. Tree diagrams allow us to see all the different possibilities that can happen. When we're talking about permutations and combinations, we're really talking about chance. What's the chance of something happen? How likely is something to happen? If you were to go to Vegas and gamble and roll dice, there's a likelihood that you can get certain numbers over others. And we want to know, what are the chances we're going to get something like that? So we're going to start out with a simple tree diagram, and we're going to diagram what are the possible win-loss records for the Cavaliers after 3 games, right? So what could the Cavaliers' record be after 3 games, knowing that they can either win or they can lose? So what we always start out with are our events, or what are our events or our number of possibilities. So we're talking about 3 Cavalier games. So my 3 events, my 3 things that are happening are, we have game number 1, game number 2, and game number 3. Now, for that first game, the Cavaliers can either win or lose. The possibility is they either win or they lose, right? For game 2, they can also win or lose. Now, when we draw a tree diagram, we have to draw different branches. It's kind of like if they win, they could either, for the next game, they could win or lose. So if they win the first game, they could either win or lose the second game. If they lose the first game, they can either win or lose the second game. So now we have 4 different branches going on because there's 4 different things that can happen, right? They could technically, if we're just talking about games 1 and 2, they could win, they could win, lose, they could lose, win, or they could lose, lose. Those are 4 different outcomes that are different, right? Now we're talking about 3 different games happening. So if they won the first game, right, they won the second game, while on the third game, they could either win or lose again. If they won the first game, they lost the second game, then the third game they could either win or lose. If they won the first game, they lost the first game, they won the second game. On the third game, they could either win or lose. And then finally, if they lost the first game, they lost the second game. On the third game, they could either win or lose. So you see that our tree has gotten a lot bigger. Now what we can do is we want to know the number of possibilities. We can always count the final branch, okay? So this is like the final branch of our tree right here. We know that there is 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes for their 3 games. So let's kind of discuss what those 3 possible outcomes would be, right? First, we have win, win, win. So our first outcome would be win, win, win. Then we'll have win, win, lose. So win, win, lose. We have, let me use a different color so you can see, win, lose, win. Win, lose, win. Okay, and notice I'm kind of coloring underneath the letter so you can see where I'm getting each of these possibilities from. We can have win, lose, lose. There's the next one. Win, lose, lose. Right? And see, we've already taken care of our first 4 end branches. Now we're going to come down to where you start with losing. So we could have lose, win, win. So lose, win, win. We could have lose, win, lose. We could have lose, lose, win. And then finally we could have lose, lose, lose. Alright, now, when I look at this, if you were to figure out what the likelihood of them winning would be, winning all 3 games, and I asked you, well, what are the chances that they might win all 3 games? You would say, well, they really have 8 different outcomes that can happen after 3 games, right? Here's our first, second, third, fourth, fifth, sixth, seventh, and 8th outcome. And if I said, what's the possibility that they're going to win every single game? You could say, oh, well, there's only one way for that to occur, win, win, win. So that would be a 1 in 8 chance. If I said, what's the possibility that they're going to lose every single game? You'd say, oh, well, that's only one way that can happen. That's lose, lose, lose. And that's a 1 in 8 chance. They can have 1 out of 8, every 8 chances. They might lose every single game. Let's look at B. It says, how do you get a 2-1 record? Now, when we talk about basketball, records are determined by, and I'm going to write this over here, wins to losses. And so if I would write this first one out as a win-loss ratio, I would say that their record was a 3 in O because they won 3 games and they lost 0 games. For that second possibility, I would say they won 2, but they lost 1. For that third, they won 2, but they lost 1, right? Even though it was in a different order, right? In the second possibility, they won 2 games in a row but lost the last. The third, they won 2 games on either ends but lost the middle, but they still have a 2-1 run record. The fourth possibility, I'd say that they won 1, they lost 2. Remember, lost the second? We could say they won 2, they lost 1. They won 1, they lost 2. They won 1, they lost 2. And they won 0, they lost 3. So how could the team get a 2-1 record? Well, let's look. What are the possibilities that happened? We can get it here, so that's 1, 2, 3. There's 3 ways of getting that. So how do we write that down? How do you get a 2-1 record? Well, we say, okay, what's the desired number? Or what is it that you're trying to find? The desired number out of the number of total possibilities. Well, so what is our desired number? We're looking for the ways that you can get a 2-1 record, and we found that there was 1, 2, 3 ways of getting that. So we have 3 ways. And what are the total number of possibilities? Well, there are 8 different ways that the Cavaliers record can go after playing 3 games. So you'd say that they have 8 total possibilities. So then how could the team get a 2-1 record? Well, they have a 3 in 8 chance. Let me ask you another quick question. We're going to add this one at the bottom. Let's say I said, well, what's the Cavaliers' possibility of having a 1-2 record, right? Same thing. Let's look. Well, that's saying they won 1 game, but they lost 2. How many ways can that occur? We have 1, 2, 3. So what are the total number of ways that can happen? Well, 3 out of the total number of possibilities, which is 8. So again, that one would also be 3 out of 8. If I asked you, okay, what's the possibility that they're going to win all 3 games? So they have a record of a 3-0. Well, there's only one way they can win all 3 games, and that's win, 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 win. So we'd say that that has a 1 in 8 chance. So a tree diagram, what it really does is help us see all the different possibilities. Okay, all the different possibilities. If we were looking at this and I had to say, well, is this a combination or a permutation? I would say that this is a combination because we're talking about the team's record. At the end of the day, it doesn't matter what order they won the games in, as long as at the end of 3 games, they have 2 wins and 1 loss. If they won 1 loss or they won, lost 1, they still have a record of 2-1. So this would be a combination because the order doesn't matter. It doesn't matter what order that they actually win the games in. We're just looking for what their record is. Let's do another example of a tree diagram because I think it's important that you understand what we're trying to figure out when we do combinations and permutations. So example 2 says your advisory has an option of wearing red, blue, or white shirts. They also have a choice of wearing jeans or khakis and black or white shoes. Use a tree diagram to determine the number of possible uniform combinations. Now, first thing we want to do is draw a tree diagram. So the first thing we should do is label our 3 categories. We're picking between shirts, pants, and shoes. So I'm going to label those at the top. Shirts, pants, and shoes. All right, now think about we have 3 categories: shirts, pants, shoes. What are the options or what are the possibilities underneath shirts? Well, we can have a red, blue, or white shirt. So I'm going to say we can have a red, a blue, or a white shirt. Then, what are our possibilities for pants? Well, we can pick jeans or khakis. So if we pick the red shirt, then we can pick jeans or khakis. If we pick the blue shirt, we also can pick jeans or khakis. If we pick the white shirt, we also can pick jeans or khakis, right? Because no matter what shirt we pick, we still are going to have the same pant choices, so jeans or khakis. Now, if we pick shoes, we have black or white shoes. So that means if we pick a red shirt and jeans, we're going to pick between black and white shoes. If we pick a red shirt and khakis, we're going to choose between black and white shoes. If we pick a blue shirt, jeans, we're going to choose between black and white shoes. If we pick a blue shirt and khakis, we're going to choose between black and white shoes. A white shirt and jeans, we're going to choose between black and white shoes. And then again, if we have a white shirt and khakis, we're going to choose between black and white shoes. Now, what are the number of possibilities? Remember we talked about the last branch, right? This branch right here tells you the number of total different combinations you can have, the total different number of possibilities. So if I count up this last branch, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possibilities. Now, of those 12 possibilities, what are the chances that you get a certain kind of possibility, right? So I might ask you the question, well, of these 12 possibilities, how many have a How many have a red shirt? Well, if we look, we could have a red shirt, jeans, black, red shirt, jeans, white, red shirt, khakis, black, red shirt, khakis, white. This set of 4 possibilities has all red shirts. So how many have a red shirt? Well, we could say that there are 4 possibilities with a red shirt out of 12 total possibilities. We want to make sure that we reduce that. So that means we have a 1/3 chance, a 1 in 3 chance of having a red shirt. Okay, what if I asked you how many with black shoes? So what's the chance of having an option with black shoes? Well, let's look at just how many that there are with black shoes. We have 1, 2, 3, 4, 5, 6. So 6 out of a total possible combinations of 12, that means you have a half of a chance of wearing black shoes. Now again, we should say, all right, looking at this, is this going to be a permutation or is this going to be a combination? This would be a combination because the order that you wear your outfit doesn't matter. So if I wear red pants or a red shirt, jeans, and black shoes, it's the same as wearing black shoes, jeans, and a red shirt. It doesn't matter what order I say my outfit in, I'm still wearing the same outfit. Alright, that is the end of this first video. That's just giving you the basic on what a permutation and a combination is, what we're trying to figure out. The next video, we're going to talk about a smart cut that you can use to find permutations and combinations. So go ahead, make sure that you don't have any questions, write any questions down that you might have, and get ready to talk about tree diagrams in class.